Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome, front-end developers. Today, in this explainer, we're going to level up your prototypes by shifting them from fragile local storage to a secure, production-ready cloud backend. Seriously, if you have ever built a really slick React app only to realize that all your data just vanishes into thin air the second someone switches devices, well, you're absolutely in the right place.
So here is our game plan for today. We'll start with Section 1, the limits of local storage. Then, Section 2, the NoSQL mental model. 3, React and asynchronous CRUD. 4, the front-end security illusion. And we'll wrap up with Section 5, enforcing real data security. Let's get right into it.
Section 1. Limits of local storage. Breaking out of the browser. We really have to address the elephant in the room here. Saving tasks locally in an app, it works great, right up until the exact moment you hit those first real limits. The second you clear your browser, your app suddenly has the memory of a goldfish. Trying to use a second device? Forget about it. Nothing transfers over. And sharing a simple to-do list with a friend is effectively impossible. These aren't just minor technical quirks. They're the exact roadblocks that keep a simple, personal project from evolving into a real, secure, multi-user project.
Moving your app to the cloud means you have to completely shift your design mindset from thinking about my browser to thinking about my user. Local storage is synchronous, it's totally browser-bound, and it's instant. Cloud Firestore, on the other hand, is asynchronous, it works across multiple devices, and it's absolutely subject to network latency. That shift changes the user experience at a fundamental level. Your data now lives with the user and actually travels with them. For something like a to-do app, that means every single task has to be tied to a specific user, it has to survive when they swap devices, and it absolutely must be protected by explicit permission rules.
Section 2. The NoSQL mental model. Rethinking relational data. To actually make this jump successfully, we've got to leave behind our rigid relational SQL habits and start embracing a totally flexible new database paradigm. Cloud Firestore is a document-based NoSQL database. So unlike SQL, our goal here isn't about modeling complex relationships between tables. It's all about speed and flexibility. Think about how familiar SQL architecture maps over to Firestore's NoSQL structure. Your traditional table becomes a collection and a row becomes a document. But the real game changer is that final concept. We drop those complex joins entirely in favor of simple embedded references. Instead of looking up a user through an external key in some separate table, every task just carries the user's ID as its own field. Now, if you're coming from SQL, that might look a bit redundant, but honestly, it's exactly what makes it possible to filter tasks by user in one single lightning-fast query without any extra operations.
In Firestore, design starts from the query. In the SQL world, design usually starts from the entities and their relationships. But in NoSQL, we completely flip that script. Instead of starting with tables, we start with our core immediate need. We ask, okay, give me every task belonging to this specific user, ordered by its creation date. That one single query determines absolutely everything else. It means every document needs a user ID field to identify who owns it, and a created app field to sort it. You decide what needs to be displayed or sorted first, and then you just structure your documents to make that happen.
Moving on to Section 3. React and asynchronous CRUD, wiring up the front end. Let's switch gears, head over to the front end, and see how this all builds into our React codebase using Firebase's modern modular version 9 SDK. This modern version is built around independent function imports. That means you only pull in the exact utilities your app actually uses, which keeps your final code incredibly light and fast. Because we're swapping out instantaneous local storage from network requests that are subject to latency, our user interface now has to explicitly manage 3 inevitable states of async CRUD. Back in local storage land, saving a task was just one instant line of code. But in Firestore, every single function that talks to the database is asynchronous, so any component triggering those operations has to manage the data itself, a loading boolean, and a potential error state. If you skip error handling here, you're just going to leave your user staring at a totally frozen screen whenever a network hiccup happens. And in a real production-ready app, that's simply not going to cut it.
Now here's something you'll definitely run into. When you write a query that combines a filter for a user with a sort by date, you are going to hit an expected missing index error. Don't panic. It's not a bug, it is totally by design. And honestly, this is where Firestore pulls off a pretty great magic trick. It gives you a direct link right there in the console error message. You just click it, Firebase pre-fills all the necessary fields, and you just hit confirm. The index builds quietly in the background, and suddenly your query works perfectly with zero code changes on your end.
Before we jump into security, you can quickly verify this new asynchronous architecture by running through 3 really simple tests. First, load the app as a few different users to confirm their data is completely isolated. Second, create a task and make sure it pops up instantly without needing a hard browser refresh. And third, my favorite, just cut your Wi-Fi. Seriously, interfere with the network connection to verify that your loading and error states are actually giving the user helpful, understandable feedback.
Section 4. The front-end security illusion. The danger of test mode. We've got our data flowing, our loading spinners are spinning, but now it's time for a plot twist. All this great code leaves us vulnerable to a catastrophic mistake if we rely on the wrong defenses. When you spin up a new Firebase project, you often start out in test mode. That means anyone who happens to know your public project ID can read, write, and even delete every single document in your entire database.
So that brings us to a massively crucial question. If we filter our tasks by the user ID right there in our React component, is our multi-user database actually safe? I mean, we might write a query in our front end that explicitly says only show tasks where the user ID equals the current logged-in user. That looks perfectly secure on the screen, right?
The answer is a terrifying no. Anyone with your public project ID can bypass that UI filter entirely. You see, the front end is just the face of the app. It's absolutely not the custodian of the data. Literally anyone can pop open their browser console, use a tool like Postman, clone a request, and pull out data they have no business seeing. Filtering in React is great for user experience, sure, but it provides zero real protection on its own. Real, actual protection has to happen on the back end.
Which brings us to our final stop, Section 5, Enforcing Real Data Security, Backend Rules and Tenancy. To destroy this dangerous anti-pattern of trusting the front end, we have to implement true security at the database level using Firestore security rules. These are declarative blocks of logic that live directly on the server. They evaluate every single read or write attempt before a single byte of data ever reaches the client. We enforce this through a concept called tenancy. Think of it a lot like a secure apartment building where a user's ID acts as the one and only valid key to their specific unit of data. In our single-tenant model, every single task document gets tagged with a user ID. The rules we write will then ensure that only that exact user can access those specific documents, keeping everyone's data completely and safely segregated.
So what does a rock-solid security rule actually look like? Well, first, we deny everything by default. That forces us to explicitly declare our exceptions. Firestore evaluates these strict rules by comparing request.auth, basically who is making the request, against resource.data, who actually owns the document. If those two don't match up, Firestore blocks the request entirely. And keep in mind, Firestore will never silently filter unauthorized data out for you. It just outright rejects the request. That is exactly why your front end still must query by user ID. It's not doing it to protect the data, it's doing it to prove to the backend rules that it's only asking for exactly what it's allowed to see.
React can request the right data, but Firestore is the one that decides whether it can actually be delivered. That phrase right there perfectly captures this whole migration journey. We moved from a fragile front-end prototype to a robust, production-ready cloud application. React's job is to build the interface, ask for the data, and manage the loading spinners. But the actual authority, the real ironclad security, lives purely in Firestore.
I want to leave you with one final provocative thought as we wrap up this explainer today. Take a really close look at your own projects. Dig into your code bases, check your Firestore rules, and ask yourself honestly, are you truly protecting your users' data? Are you just hiding it behind a fragile React filter? Because I promise you, the difference between those two things is the exact difference between a weekend prototype and a real, viable product. Keep building, keep securing, and we'll catch you in the next one.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.